Okay, 9.5a, elementary algebra, complex solutions to quadratic equations. Now, if you remember, we had, let me write this correctly, standard form of a quadratic equation looked like this. And we had a quadratic equation that looked like this. And you learned how to solve problems using the quadratic equation. Then we went into finding out radicals, square roots, and square roots of numbers that were negative. Remember, we did imaginary numbers, that kind of thing. What we're going to focus on, at least for a minute here, is this right here. B squared minus 4ac. That is called, it's got a name, that set of numbers that are under there, and it's called a discriminant. Okay, that's all that is. The number, when we solve it, when we plug the numbers in and square the b minus 4 times a times c and we get a number, that's called the discriminant. And what that discriminant does is it tells us what kind of answer we're going to get here for x. And that's really as far as I'm going to go with that right now. The book doesn't really even go that far, but that's what a discriminant is. So one of the things that you have to be aware of is that sometimes this discriminant is going to be a negative number. So if we had a discriminant and it was equal to, say, negative 12, then underneath this radical sign right here is a negative 12. And what do you do when you have a negative number under the radical sign? Because all this time we've said it doesn't exist. Well, here's the theory behind what we do. We change it to a negative 1 times a 12. Because negative 1 times 12 is negative 12. And what do we know about the square root of negative 1? That equals I. So we are going to take that and replace it with I. Okay? So when you have a square root of negative 1, just take the radical off and change it to an I. And then actually the correct way of writing this would be the square root of 12, and then you'd put the I at the end like that. And then you'd simplify the square root of 12. And the square root of 12, I'm just going to simplify it, is 2 square root of 3. And then we put the I there. And that's what would be the simplification of the square root of negative 12. It would look like that. All right, so that's the theory behind it. That's actually how to solve it, but I'm going to show you a quick and easy way to do these, and it's really not a way, it's just recognizing square root of negative 4. Whenever you have a negative in the radical, take it off and put an I outside the radical. Okay? So whenever there's a negative in here, take the negative off and put an I outside the radical, because that I actually represents the square root of negative 1, and then you've got the 4 here. So we just took the negative 1, made it into an I, and brought it out there. Okay, and then the square root of 4 is 2, so you get 2I then for I square root of 4. Square root of negative 36, bring an I out, square root of 36. That equals 6, stab the I on the end. Square root of negative 7, bring an I out, square root of 7, or you can write it as square root of 7I, which is the more which, you know, the book kind of goes back and forth on whether they give you the I in the front or the I at the end. It doesn't matter. If I had my desire or my what I would like, it would look like that, because sometimes this is going to look like the I is underneath if you kind of get carried away with stretching your I out a little bit. All right, so last one we'll do, at least on this example 1, is the square root of negative 75. And then we simplify that by saying, all right, what are two numbers multiplied together that give me 75 that I can take the square root of one of those? And then the square root of 25 is 5. And then we've got a 3. And there's your answer for that one there. So, not really too bad. So let's go to example 2. And example 2, let's get rid of my stuff here. Example 2 gives us x plus 2, the quantity squared, equals -9. Turn my music down. Alright, so what we're going to do here is we have a group that is squared here. And if you remember from a while back, if you square root that side, square root that side, then our exponent leaves, and we get plus or minus the square root of -9. So far, so good. Now, square root of -9. Take the negative out. Remember, you put an I there, and you get a 9. And what is the square root of 9? 3. So you have a 3i there. All right, so now we're going to subtract 2 from both sides. Get x by itself. So we're going to get -2 plus or minus 3i. And I put it that way because remember it needs to be written in this format where the number's first and then the number with the I is second. And that is your answer there. That's as simplified as we can go. All right, example number 3. Okay, example number 3. You should be pretty familiar with this when you get these fractions on here and you have an equal sign and you want to get rid of a fraction. You multiply the entire thing by the greatest common factor, or the least common denominator, I guess is what it would be, which in this case is 10, because 10 goes into 10, 5 goes into 10, and 2 goes into 10. So if we multiply everything by 10, we get 10 over 10x squared minus 10 over 5x equals -10 over 2. So this becomes a 1, x squared minus 10 over 5 is 2 equals -10 over 2 is -5. So our fractions go away. We move that 5 over to that, and that looks a heck of a lot better. And of course we try this to see if there's two numbers multiplied together that give me 5 and added give me 2, and the only two numbers multiplied together give me 5, or 5 and 1, and I can't get a -2 out of that. So I know that isn't going to work. So my other option is completing the square or, using the quadratic formula. So x equals -b plus or minus the square root of b squared minus 4ac all over 2a. Oops, got a little bit carried away with my parenthesis, or my line. All right, so now I've got an a of 1, a b of -2, and a c of 5. So I'll just plug those numbers in. X equals negative, what is b? -2, plus or minus the square root of b squared minus 4ac all over 2 times a. Okay, so I have all that stuff there. Now I'm going to go and simplify. So let's see if we can get some of this junk out of my way here. Alright, so x equals -2 is a positive 2, plus or minus. And our discriminant, the numbers that are in there, 4 minus 20 over 2. So x equals 2 plus or minus 4 minus 20 is negative square root of 16 over 2. And again, we're going to keep simplifying what's in that radical sign. I square root of 16 over 2, which equals 2 plus or minus 4i over 2. Alright, so once we have that, we can look at this top and see if it can be simplified. We can pull out a 2. Cancel, cancel. And our answer is 1 plus or minus 2i, which means our x is going to be 1 plus 2i or 1 minus 2i because of that plus or minus sign. And that's it. All right, example number 4. All right, so there's example 4. What we're going to do is we're going to multiply the binomials here. So we're going to use the FOIL method. So first would be 4x squared outside, inside, and last. Combine these. Add 4 to both sides so we can make it equal to 0. You always want to do that with these quadratic equations. Make them equal to 0. Get everything on one side and the 0 on the other. All right, so there we could go with the mess of 4 times 7 is 28, and then find two numbers multiplied together, give me 28, added, give me negative 8. And you would find out that there are none. So that means you have to use the quadratic equation. And again, I just suggest you write it out every time just so that you start memorizing it instead of having to go and look at your notes every time. Alright, so my A is 4, my B is negative 8, and my C is 7. And it's always good to write that out too. So your negative 8 is your B, plus or minus the square root of negative 8 squared, minus 4A, C, over 2A. Alright, so that's what we need. So let's move everything else up. And what do we have? 8 plus or minus 64 minus 16 times 7, 112 over 8. And one of the things I want to remind you, this line here goes all the way across. A lot of people stop right here. And the 8 isn't in the fraction sign, but it is. It's the entire thing. Alright, so that gives me 8 plus or minus negative 48 all over 8. So we're going to take that I out, and that gives us 8 plus or minus the square root of 48, and we've got an I out there now, over 8. And will the square root of 48 reduce? Let's see, two numbers multiplied together give me 48. One of them I can take the square root of. I've got 4 and 12. I've got 16 and 3. This one is the one I end up wanting because this one I can take the square root of, but this reduces, so I don't want to use that. I want to have to do reducing. This is the one I want because the 3 won't reduce. So I get A plus or minus square root of 16 is 4 with the 3 left over in there, all over 8. So see what I did? I changed this to the square root of 16 times 3, and then I took the square root of 16, and that's how the 4 came out and the 3 stayed in there. Okay, so sometimes I do a lot of this in my head, and then you're like, what in the world did he just do? Alright, so now I'm at this point here. So let's look at the top and see if we can factor anything out. We can factor a 4. Okay, and this is 1/2, so that reduces to a 2, and this is a 1. So I have 4 plus or minus the square root of 3, whoops, don't forget my I there, over 2. And that ends up being my final answer. Except one of the things that we need to put it in this form. So we need to split these up. So let's do that. 4 over 2 plus or minus I square root of 3 over 2. And 4 over 2 is 2. So that ends up being my final answer there. Okay? And again, the book puts the I at the end. Sometimes they put it at the front. So we're just going to kind of leave it there. So next video will just be over a little bit on the problem set, but that's it for 9.5.